Okay, hi guys. So in this lecture, we'll be continuing on seeing some more examples on the Reimer-Tieman reaction and the abnormal Reimer-Tieman reaction. Okay, so let's get started. So we have something like this example. Okay, and we are reacting it with again chloroform in basic medium. Okay, and we are heating it. What will happen? Again, OH minus will actually attack with the chloroform and we'll get something like CHCl3 or rather CCl3 minus. This CCl3 would form a carbene with a release of Cl minus. Okay, again this OH minus will be acting on this alpha and acidic hydrogen atom and we'll get something like this compound. Okay, which is resonance stabilized. This compound, the benzene, which will act on the benzene ring and we'll get something like this. Okay, Cl2. Okay, next what will happen is this hydrogen atom would be taken away again by the OH minus, and as a result the bond will be breaking and this bond would also be breaking. So would this be taken by the OH minus? No, this won't be taken by the OH minus. We would have rather this bond breaking up, this bond coming and forming a double bond with this carbon atom. Okay, and one of the two Cl minus or one of the two Cl2 would be leaving the compound. Okay, so in the end what will we be getting? We'll be getting something like, and this bond with Cl. Okay, so let us see another example. We'll have something like this compound and we are reacting it with again CCl3 in presence of OH minus. What will now happen is again we are heating it and the second thing we are passing on is H plus. Again what will we be getting? We'll be getting something like, obviously this will be converting into CCl2 a carbene and we'll be getting, and again this OH minus will be attacking on this phenol compound or phenol like compound and we'll get something like resonance between the OH and the, or between the lone pair of oxygen atom and the corresponding pi electrons of benzene. As a result we'll be getting something like a negative charge density on this carbon atom. Okay, and then this negative atom, negatively charged carbon atom, will be attacking on the carbene. Okay, and we'll get something like this structure. Okay, now what will happen is we also have H attached here. This H atom would actually form a, this C and H bond will break and H plus would be released, and as a result we'll get, there is also a negative charge here, we'll get a double bond between this carbon atom and this carbon atom, and this negative charge would actually take on the released H plus, and also the bond between C and O would be broken up and we'll get O minus here. Okay, and we'll get CHCl2. Okay, now what will happen is again OH minus will be again attacking on this carbon atom. Okay, and as a result we'll be getting something like this carbon atom, and as a result we'll be getting something like minus CHOH Cl, and again OH minus will be again attacking on this carbon atom, and so we'll be getting something like geminal diol. Okay, CHOH and OH. Geminal diol again would be unstable, and as a result water molecule would be dehydrated, or water molecule will be leaving this compound, or dehydration would happen when we heat this. Okay, so we'll get something like CHO and a phenyl ring attached. So this would be our major product. How this O minus converted into OH? Oh, this is still O minus. Okay, and on heating and on providing acidic medium, the O minus will again attack on H plus and will get something like this product. Okay, now let's take another example. We have something like OCS3 here, and we have again a Reimer-Tieman reaction, see chloroform in presence of OH. So what would be, and second we are passing H plus, so that the O minus converts into OH again. So what would be the major product of this reaction? The major product of this reaction would be something like this. OH OCS3 would be here, and we'll get something like CHO here. Why is this the case? Because of the presence of steric hindrance. Okay, so here is less steric hindrance. Okay, so this CHO would be attacking on, or would be attached on rather, this carbon atom. Okay, now let's see another reaction or another test, which is called isocyanate test, or it's also called carbylamine reaction. Okay, so we have something like RNH2, and we are again passing CHCl3 in presence of KOH. So what would be the major product formed? So we have something like a primary amine. Okay, and we are passing it in presence of CHCl3 and KOH. Okay, so what will we be getting? We'll be getting something like this product. This is foul smelling. Okay, or unpleasant smell. Okay, and primary amine reacts with, in this reaction, in just to write it in notes, that primary amine reacts with chloroform and base to form isocyanate, which is also called isocyanate test. Okay, so it's a test for primary amine. Okay, so let me write it down. Primary amine reacts with chloroform and base to form isocyanide, and this is known as isocyanate test. Okay, so in the next lecture we'll be covering up mechanism of isocyanate test or carbylamine reaction. Till then, good luck and goodbye.